So yeah, hi everybody. Happy to be here. I'm Matthew Shaxted. I'm going to be presenting kind of a whole bunch of different, I'd say more high level information on how we've been applying Parsl in different science and industry applications, and then just kind of give an update over, really the last few years of new platform features, enhancements, things we've been kind of doing to really disseminate workflow across industry. So here's some of the things I'm going to talk about. I'm going to give a little overview of Parallel Works, going to talk about updates, recent updates, and then kind of a near-term technology roadmap that I think intersect with a lot of the earlier presentations that we heard. And then finally show some applications, calling it Parsl in the wild, but we work with a very wide variety of customers in different industries, different domains. So we're just going to sample a few of them. I know we're near enough time to look at all of them, but we'll show some. We'll try to get through this quickly. Alvaro is going to get into more of like live demos, showing you what you can do with some of the new capabilities on the platform, which I think should be kind of interesting. So what is the system? We are a middleware platform. We started about, I think, over 6 years ago now, spun out of collaborations with Mike Wild at Argonne and UChicago, and then we went through the University of Chicago Innovation Fund, it was called back then, and started the company and have been kind of pushing along ever since, really building initially on Swift, which was the precursor to Parsl, and now we've kind of fully integrated Parsl and kind of continuing that development as well. Next, we're looking at FuncX, but that's in the roadmap. So really this slide at a glance summarizes what we do. If you think of us in this middle area, we really connect a wide variety of on-prem resource managers to elastic cloud and HPC resources. And we do that in a way that tries to make it uniform between all of them, and then give really more, I'd say, organizations is where we've been kind of targeting now, larger organizations, a uniform interface to run their executions, develop their mostly proprietary workflows, and then deploy them and disseminate them across their user base. So here's a few slides of what that looks like. So we give users a web-based interface that looks like this. Anything you can do through the interface, you can also automate with an API, to REST API. So we have customers that go on and automate clusters and these different resource providers, and then actually launch Parsl workflows with an API, which is, I think, kind of interesting. Some of you may look at this screen and remember or see hints of the Galaxy bioinformatics kind of web tool. We actually started on that code base, and we pretty much ripped almost all of it out, except this front end pane system right now, and then a little bit on the job execution piece. But we like some aspects of it, and we reused also the form generator. So when you build a Parsl workflow in our system, you can also define a JSON or XML based form, kind of a no code in a no code environment, drag and drop different web UI elements, and it creates this easily disseminable form that you can plug in your inputs, hit execute, and run computation. We also have a solution marketplace or a solution library where users either within an organization or kind of publicly can share the workflows they produce. And this becomes a way to kind of build, I guess, persistent knowledge base, institutional memory related to these most, usually complex workflows that are specific in an organization. You're seeing some of the examples that we have on our SaaS platform right now. And all these are really fully packaged Parsl workflows with a front end, web form that the workflow builder designed. And they're designed to either run on like a single resource location, or they can span multiple resources. And then we give all of our users a fully web-based IDE, integrated development environment. They can open all these different files. It kind of slides open from the interface. I think Alvaro will show that. And you can write your Parsl code. You can test it right in a terminal environment. We give users a persistent cloud-based container workspace where they're able to test all this. And it just becomes kind of a convenient place to store all your workflows in one location and get back to them and resume where you left off. So what that gives you, what our platform gives our customers is a place where they can build and deploy these multi-site workflows, and they kind of do a whole wide range of things. I'll show some of them, but here on the screen, you're looking at an example workflow that is kind of common. I think we've been seeing some of that, simple pre-process, maybe you want to do that in the public cloud, send those jobs to, maybe bare metal HPC resources, either on-prem, with a conventional scheduler, or elastic HPC providers that we work with. So Penguin Pod on demand, and then our systems is another provider for utility HPC resource, and then maybe send the jobs back to GPU nodes running in the cloud. These are the types of workflows that we support. So we've been busy over the last few years, really developing a wide range of new features that are primarily customer driven. So we work with customers, they tell us what they want, we kind of fit that into our roadmap and we develop it. So some of the features that I'll show right here, these are the things we've been busy developing. Over the last year, we've developed a new really type of provider in our system that we're calling clusters. In the cloud, you get fully provisioned Slurm with Lustre file system at the moment, clusters on AWS, Azure, GCP, and Oracle. So what this does is it lets people go into our platform. They see a little big power button. They activate that and they get provisioned in about less than 5 minutes, a fully elastic Slurm cluster with a Lustre file system, an optional Lustre file system. And we've just deployed this in a NOAA user environment with a pretty wide range of large user base there. And the kind of interesting point about this is on each of these providers, AWS, Azure, GCP, we've had to benchmark the cluster performance to meet or exceed NOAA's Hera system, which is about 64,000 core Cray Skylake machine. And so the NOAA benchmark tests we're running on each of these three cloud providers is actually exceeding the Hera performance. And that's for about a 4,000 core scale, 48-hour forecast job. So a lot of work went into, first of all, just deploying the infrastructure to get these elastic clusters provisioned quickly. And then second, a lot of work went into actually tuning each of these clusters to really meet or exceed the on-prem supercomputer performance. So that was kind of an interesting, realization for us, that the time of, cloud really getting to the point of exceeding, Cray machines is kind of here. And then it becomes a cost optimization and, what makes sense where. So that was kind of a fun new feature that's integrated in the platform. I think Alvar is going to show that. We actually started our system developing off of Swift coasters, which is kind of a, it's a lightweight Perl-based mechanism and TCP-based mechanism for executing jobs and connecting diverse resources. We kind of built on that and created a shell-based provider in kind of the coaster framework. And then we've integrated that into Parsl as well. So now Parsl can talk to a wide range of resources that we support, and they're kind of fully elastic. So we call this our elastic providers. We're adding new ones every day. You can see we support the major cloud providers. We support most major schedulers. And then we're starting to build new capabilities that we're calling like smart pools. So they let you actually set policies on, in maybe multi-site jobs where you want, a certain set of tasks to wait maybe up to 10 minutes in a Slurm cluster or a Slurm scheduler cluster. If you can't get nodes in that time, it will burst out to the cloud, things like that we're developing. And then finally, one of the big elements we've added over the last few months, we've had to create uniform cost tracking across each of the major cloud environments. So actually literally looking at all the different resources and the dollar spend on each one. We are providing a way for our customers to enforce dollar quota allocations. So just like you would on an on-prem system, instead of providing allocations in core hours and storage, this is actually providing allocations in dollars. And then we keep track of that and enforce it for our users. And then we also have, we capture a lot of data on all the node health on these clusters and all the Slurm job activity, things like that. We give this to our users in an easy to use dashboard. A few things on the roadmap. I talked about the policy-driven task placement. We are moving to deploying our base infrastructure in Kubernetes. So that will give us high availability of the system. We already deploy certain aspects of it in Kubernetes now, but we're moving there. We're unifying our provider interface. That's spawning these elastic clusters in the cloud. We're going to be using Terraform for that. We are hopefully soon going to be changing out the coaster provider with actually the native Parsl providers, and we're starting to experiment with that now. And then a lot of the great presentations today on FunkX, I think it really gets us thinking about how we can start to integrate that as a easy to use service for our customers as well. One other point I wanted to add, our customers use a wide range of workflow fabrics, actually, and we started with just Swift and Parsl, but we're kind of quickly expanding out into new workflow fabrics, kind of directly integrated into our platform. So we have some users and examples that are running Dask, talking to our different providers, Jetstream, which is a bioinformatics workflow fabric, and then a few users are starting to experiment with Prefect.io and Rakoto kind of natively being supported as additional fabrics. So we're kind of turning into this converged interface where a wide variety of workflow fabrics can talk to a wide variety of computing resources in one area. So a few examples. I know I'm kind of running out of time here. I'll just flip through these. Here's a example workflow that was created with a tier 1 automotive supplier. So they're running, this was a turbine CFD code that they're running. They created a pretty complex, front end form. They had a Parsl script running a fairly simple pre-process, parallel execute a bunch of jobs, and then post-process at the end. Each one was, I think, about 500 or so core execution at one time. And what this gave them is the ability to now run, a lot of them in parallel and get nice output results. So here are some of the screenshots from what that looks like from a user perspective. This is their account. Interesting things, they actually were mounting in their S3 buckets right into this converged IDE here and pushing and pulling data right out of there. So they have this kind of S3 data lake that they keep all their simulation results. This would just push the data right back into that. We integrated a older Parsl monitor that needs some updating, but it gives them a sense of what's going on in the workflow. The outputs came in JSON format, and so you can kind of preview it. And then they get a provenance of what happened over their many executions they were running. Also interesting, this customer had large data that they were moving up to our platform into the compute nodes and then back out. They had to pull it on-prem. We got them set up testing Globus to do that, and they were kind of pushing and pulling data right into their ParallelWorks environment for that. Here's another example. This is one we did with IndyCar. This was using a software called Dakota out of Sandia National Lab to actually do Monte Carlo sampling. And then we would have a Parsl script that runs all the cases, post-process the results, and then bring it back into a design explorer that Glenn showed a little bit earlier. So just kind of different wide varieties. Again, the form becomes something easy that now the entire IndyCar design user base can now execute these design of experiments with Dakota without actually having to learn the Dakota syntax, which gets a bit complicated. We're working with a variety of software vendors as well on enabling their softwares to run in the cloud. So we kind of call them our powered by ParallelWorks solutions. One that's been our customer since almost the beginning, Jacobs Engineering. They have a flood modeling software that connects right to our API that is executing Parsl scripts in the background. I took a little screenshot of that. Just you can see the workflow here. Interestingly, with this Parsl workflow, we added a few capabilities right into Parsl for streaming of data files back from the remote resources. So the users wanted to be able to actually see the progress of the simulations. This is streaming it back to the ParallelWorks environment where they could actually, tail it and see what's going on. And then also this Parsl workflow attached a kind of custom billing monitor that watches the interchange log and keeps track of all the job executions and runtime for the users. And that's how they're actually billing their customers. with from these Parsl interchange logs directly. And then a next application, we worked with Gamma Technologies on cloud enabling their engine modeling software. This is some of the details of what's actually going on. I don't think I'm not going to have time to go through it, but that's interesting. We're working with a number of university collaborators as well. I think Glenn showed his 3D viewer that you can see on the top right. We're working with the Zavala group at University of Wisconsin on a pretty wide range of Julia workflows. So again, this is Parsl launching Julia in like Singularity containers on-prem and GCP, at least in this case, GCP resources, but really cloud resources. And then I'll kind of stop there. Alvaro is going to next dive into some real demos on a NOAA deployment of the platform we did that kind of has this latest cluster in the cloud features and things like that. So with that, if you're interested in trying ParallelWorks, we can get you a demo account very easily on our current system that's using these Elastic providers. We could also put you on a preview list for an upcoming release that's going to have a whole bunch of new stuff, including all these Elastic clusters in the cloud we were describing. So with that, I'm going to pause and maybe hand off to Alvaro. Is that good on timing, Kyle? How did I do?
Absolutely perfect. And I just got to say, every time I see the UI, I'm blown away with what you guys have added. It looks really, really slick and very, very helpful for